Industrial Revolution 4.0, Innovations in Artificial Intelligence, Cognitive, Neuromorphic, Machine Vision, Robotics, Deep Learning, and Data Analytics are enhancing and improving our quality of life. As intelligent machines learn from their environment and execute self-error correction in order to successfully complete a task and ultimately to optimize productivity. The scope of this framework is to show several engineering prototypes illustrating industrial applications in intuitive geometric robotics as it relates to cognitive neuromorphic technologies. In this application, I have exposed all the software intellectual property integrated at a system architecture in firmware, mathematical algorithms, machine learning, cognitive software models, and neural network artificial intelligence programs. Neural geometric intuitive paradigm creates cognitive symbiosis between humans and thinking machines, fusing artificial intelligence with human intellect to enable humans to have a higher degree of cognitive intellectual output. Deep Science Engineering Platform has machine perception, allows the computer to use the sensory inputs as well as conventional computational means of gathering information, to gather information with greater accuracy and to present it in a way that is user-friendly. This could include vision, imaging, machine hearing, and machine touch. These technologies are used by industrial robotics for equilibrium, balancing, as well as orientation purposes. The core of the robotic system includes the Neuromorphic CPU in conjunction with the support of complex mathematical algorithms. Computational neuroscience is a branch of neuroscience which employs mathematical models, theoretical analysis, and abstractions of the brain to understand the principles that govern the development, structure, and cognitive abilities of the nervous system. Convolutional neural networks are networks that use many identical copies of the same neuron. This allows the network to have lots of neurons and express computationally large models while keeping the number of actual parameters. For an artificial intelligence autonomous stochastic robotic system to accomplish tasks when the outcome of actions is non-deterministic, it is necessary to apply error correction and error detection. Neuromorphic architectures. The idea is to connect all neurons on the architecture just as it is done by the human brain. Therefore, we are simulating the function of the brain in silicon, driven by complex neuromorphic mathematical algorithms. Essentially, neuromorphic architectures generate electrical signals that act as stimuli to the neurons, axons, dendrites, and synapses, very similarly as how the human brain is able to reason in real life. deep learning in artificial intelligence. Each level learns to transform its input data into a more abstract representation. For instance, in an image recognition application, the raw input may be a matrix of pixels. Convolutional neural networks is an artificial neural network capable of picking patterns for pattern detection used for analyzing images. Also used for data analysis. This frame of work presents the basic fundamentals from a system architecture. Some of the important technologies required to build a cognitive, thinking, artificial intelligence robotic system. In previous videos, I have illustrated several engineering prototypes representing actual architectural models, including telemetry system, inertial measurement system with integrated gyroscope, accelerometer, and magnetometer. These technologies are used by industrial robotics for equilibrium, balancing, as well as orientation purposes. The core of the robotic system includes the Neuromorphic CPU in conjunction with the support of complex mathematical algorithms, software Kalman quaternion filters, servo motor control algorithms. There are other programs embedded in this robotic application within the realm of artificial intelligence paradigm, that is machine learning, cognitive mathematical representations, and convolutional neural network software models. Smart glove and bionic hand illustrating software algorithms, firmware integration, and artificial intelligence. Bionic hand artificial intelligence. Electrode sensors are placed on two nerves, that is the ulnar and median nerves, located in the human arm. These nerves normally would allow for certain sensations in the hand. The idea is to electrically stimulate those nerves, thus transmitting the signal to the smart glove and the bionic hand fingers to enable it for dexterity. The bionic hand receives information from the brain via the ulnar and median nerve, thus providing sense of feel, touch sensitive, essentially creating a loop to let the bionic robotic hand to communicate with the brain. Motor software. Here is an illustration of the software models which activate the motor movement. The software is created with C++ and Python, integrating solutions for pulse width modulations by controlling several analog ports located on the main computer digital platform. Wi-Fi communications protocol. Data is sent over Wi-Fi to any IoT device, including a PC computer and/or an Android device. It also communicates with the bionic robotic hand in order to control neural movement of all bend sensors and joints. Neural engineering technology. Artificial intelligence refers to a broad category of computing system is able to learn directly from data. It is made possible by the augment of data analytics and applied by the introduction of machine learning processes together with deep learning methodologies. Deep learning applies to neural network. It is a subset of machine learning, integrating neural network techniques that enable systems to learn from large amounts of data